Hi AFM students, this is Miss Van Vickle, and this is your second video in our series of videos on sequences and series word problems. And I'd like to do two problems for you. The first one is problem number 3. The owners of a certain store reduce the price of their items each week if the item does not sell. If the original price of a blouse was $250 and its price at the end of each week is 4/5 of the previous week's price, what will be the price of the blouse at the end of the 10th week? So what I notice is that I have something that's geometric. And the reason I know that is the price of the blouse is going to be 4/5 of the price that it was the week before. Sometimes it helps me to write out the first few terms in the sequence that I'm dealing with. So you'll notice right here, the blouse started out to be $250. And if I multiply that times 4/5, at the end of the first week, it would be reduced to $200. And then again, at the end of the second week, it would be reduced to $160 and so forth. So that tells me clearly that I'm multiplying by 4/5 each time. And since I'm multiplying, I have a geometric sequence. So I also notice that they're asking me not for a sum, but for the price of the blouse at the end of the 10th week. So I want to find the nth term of this geometric sequence. So I use my formula a sub n is equal to the original amount times r to the n minus 1 power. So I'm looking for a sub 10 because they've asked me what is the price of the blouse at the end of the 10th week. So I want a sub 10, and that's equal to the original price of $250. And we're reducing it by 4/5 each time. And I take that to the n minus 1 power, which would be 10 minus 1, or the 9th power. So remember, you have to take 4/5 to the 9th power before you multiply by 250. And if you do that, you'll see that the blouse ends up being $33.55 after 10 weeks. I think I'd wait for that price. So the next problem I'd like to do for you is problem number 4. And it says a pile of logs has 1 log in the top layer. So I have a log right here. And then 3 logs in the second layer. So 3 logs in the second layer and 5 logs in the third layer. And so forth. And it says how many logs are in the pile total if it contains 25 layers. So if I write out the first couple of terms, 1, 3, and 5, what I notice is I'm adding 2 each time. So in each successive layer of the log pile, I add 2 logs. I notice that this is an arithmetic sequence, and I'm being asked to find the sum of a finite number of terms. So the formula that I want to use is given right here. S sub n is equal to n divided by 2 times the sum of the first and the last numbers in my sequence. So I'm looking for S sub 25 because I'm looking for the number of logs in the whole pile if I have 25 layers. So I'm looking for the sum of the first 25. So that's 25 divided by 2 times 1 plus 49. Now, where did I get this 49? I don't know yet the number of logs in my 25th layer. So I had to drop back to the formula to find the nth term. I want to find a sub n, so I want to find a sub 25. Let me scoot the camera over. I need to go back to this formula. A sub n equals a sub 1 plus my common difference times n minus 1. Because I need to find how many logs are in the 25th layer. So if I put in, there was 1 log in the first layer, my common difference is 2 because I'm adding 2 each time. N minus 1 is 25 minus 1. And I sort out this arithmetic, I find out that in the 25th layer, I have 49 logs. So this is how I had to back up to find what goes right there. So let's back up. We're finding the sum. of the first 25 layers. So I've got 25 over 2. I'm adding the first and the last terms, 1 plus 49. And again, if I sort out the arithmetic, I find that the sum of the first 25 layers has 625 logs. So I'm going to turn off the video. Again, I want you to try your homework. You should know how to do all the problems on the Sequences in Series Word Problems worksheet by now, except for the bouncing ball problem. And that I'm going to address in the next video.